4G was characterised by smartphones being connected to base stations having a big cabinet of electronics sat next to them doing all of the processing that goes with that. 5G will be very disruptive, so 5G won't be just smartphones, it'll be connected cars and it'll be robots and drones and all sorts of different user equipment devices connect to base stations of all sorts of different shapes and sizes as well. So we'll have small cells and we'll have macro cells and we'll have Cloud RAN and Edge RAN and all sorts of different configurations. These configurations of base station will be driven by standards such as O-RAN, which allow different parts of the base station to be separated from each other and configured in a very flexible way. Different flexible configurations and deployments of base station will come hand in hand with different implementation architectures. So while small cells may use an ASIC implementation for their signal processing, we can expect that macro cells and Cloud RAN implementations would have much more of a focus on FPGA and software. So this allows a very flexible migration between different bits of signal processing being implemented in different ways. You may expect that the heavy processing of LDPC to be performed in hardware, on FPGA for example. Other parts of the signal processing like polar coding could be put in software in a very flexible way.